The terms casket and coffin are often used interchangeably, but their use as synonyms is no open and shut case. Coffins are actually those 8-sided burial boxes that are narrower at the bottom. Think Dracula. Whereas caskets are rectangular. They can be made of metal, plastic, or wood. Whether the wood is ash, oak, mahogany, or something else, the casket's construction is generally the same. First, they run wood slats through a machine called a molder. This profiles the edges, carving a tongue on one side of each slat and a groove on the other. A worker applies glue to these edges, then positions the slats in a rounded vise that locks the tongues and grooves together. The glue dries in an hour and a half, bonding the slats permanently into a large curved piece. This piece will form the top and long sides of the casket's rectangular cover. To complete the rectangle, a worker now makes a V-shaped cut on each side and glues in a triangular piece of slatted wood. While a press clamps the components tightly together, he secures the end pieces in place with joint fasteners, which are like heavy-duty staples. Now a machine carves a groove into the cover's underside at the midpoint. A worker glues in a wooden piece, securing it with joint fasteners. This piece is called the bridge, and it's the point at which the cover will be cut in half later on. They transfer the casket cover to an automated machine that gives it a rough sanding, then a finer sanding. The next step is to attach a decorative molding to the base of the casket cover. This molding has a groove on the inside into which they'll later tuck the edge of the casket's upholstery fabric. A worker glues a small piece of wood in the groove at the midpoint so the groove won't show when the cover is open. Now he saws the casket cover in two, right through the bridge. Meanwhile, another worker assembles the bottom of the casket called the box. He glues together the sides and applies a bottom molding, securing everything with joint fasteners. At this point, the box is upside down. He attaches the bottom, then flips the box right side up. Now it's time to join the cover and box using 4 hinges. They spray the casket with one of countless shades of wood stain, then rub it in equally over the entire surface. The casket goes into an oven for an hour to dry the stain. Next, a worker sprays on 2 coats of lacquer with 40 minutes drying time between applications. This happens to be a high gloss finish, but many models have a duller sheen. Once the lacquer dries, a worker attaches handles. The more expensive the casket, the fancier the features. This higher-end oak model with decorative corners has wood and metal swing handles. Other models have all-metal swing handles or fixed bars made of wood, metal, or both. The fancier caskets also have an adjustable wooden bed inside with a mechanism to adjust the height. A worker covers the bed in fabric. The base model bed is made of absorbent paper laid over a product called wood wool, which is simply shredded wood. The upholsterer lines the inside of the casket with foam, covering it with either velvet, satin, or silk polyester crepe. By folding, nailing, and stapling this fabric a certain way, she creates pleats, tufting, and other design details. Generally, the more expensive the casket, the finer the fabric, and the more ornate the upholstery. A decorative trim hides the staples. Fabric straps or metal elbow brackets hold the cover open. When it comes to how beautiful and elaborate caskets can be, the ground's the limit.
A pulley is a wheel with a grooved or barreled rim in which you run a rope or belt. It's a simple device used to lift a load that's hard to access or too heavy to move by hand. Pulleys and multiple pulley systems are vital components of many types of machines. These pulleys are designed for use in small to large-scale electric motors. For example, fan belts in the air circulation systems of office buildings, factories, and mines. The factory makes its pulleys from a 50-50 mix of scrap iron and steel. The furnace heats the metal to 1,370 degrees Celsius, slightly above the metal's melting point. Workers adjust the chemical composition by adding carbon and silicon. The right recipe is essential for producing quality metal. In the furnace, the metal's impurities, called slag, rise to the surface. Workers use giant paddles to skim it off. Once the lab analyzes and approves a sample, they transfer the molten metal by ladle to a 30-ton holding furnace. This furnace maintains the metal at a constant 1,370 degrees Celsius, the required temperature for a proper casting. You can't pour metal this hot into a metal mold. The mold would just melt. So instead, the factory uses damp sand. Sand withstands intense heat by absorbing it. The machine forms the molds much the way you'd use a pail to form a sandcastle. It first constructs the bottom half of the mold. This filter will screen out any slag particles the molten metal may still contain, and these cores create empty spaces within a part. Now the machine forms the top half of the mold. They slip a weighted metal jacket around the finished sand mold. This keeps it from collapsing under the weight of the metal. Workers fill the molds right to the top. It takes from 30 to 45 minutes for the molten metal to solidify. They remove the weighted metal jacket, then dump the mold into what's called the shakeout. The vibration breaks the sand mold apart, releasing the metal pulleys. While the pulleys go off to be cleaned, the sand is recycled into new molds. The pulleys are in rough form. They still have to be machined to specifications. A robot places each one under a computerized camera. A visual recognition program guides the robot to position the pulley properly in the various automated tooling machines. The first machine makes the pulley's grooves. The next machine will drill holes in the hub for installing the screws. At the end of the machining process, a gauging system takes precise measurements and guides the equipment to correct any errors. This is a two-part pulley known as a variable pulley because it can run a belt at variable speeds. This tooling machine performs several operations on the male component. It machines the face and outside diameter on one side, then flips the pulley over to make the bore and threads on the other side. The last operation drills holes for two screws that will affix the pulley to the shaft of the electric motor. A touch of lubricant, and the next machine assembles the male and female parts. After setting the proper speed, the user locks the parts in position with a screw.